Welcome to the channel where all you gotta do is build the Batshit Bronco. So this is the CAD that I have for Bronco. This project's been going on for many years, but I've been working full time, so I haven't really had a lot of time to make progress on it. But some of you will recognize the CAD and the color of the Bronco out in the shop and some of the suspension stuff. So um, that doesn't just grow that way. I kind of noodle it out here and figure out where things are going to fit and what the suspension geometry is before I get too far. So I'm going to kind of twirl this around a little bit. So zoom in and out and kind of explain what I'm doing and why I'm doing it. And some of the stuff you'll recognize if you've been to the Facebook Batshit Bronco Facebook page. So there's some posts on there that I'll get into maybe a little later, but this is the gauge cluster. There's a post in there on that. This crazy shifter, I think there's a little video in there on that. Maybe I'll make those all into a YouTube video. This is this is currently designed for the steering brake setup, one caliper for each wheel, so you can lock and unlock differentials and right. Yeah, let's see. So I'm gonna just jiggle this around a little bit, kind of show all the pieces, and then I'll kind of take some of them out of there. This is a gross simplification of a 4.6 two-valve motor. There will be an Allen supercharger on top of it. As well as a GT42 ball bearing turbo, not compound. So the supercharger provides boost to the motor up to 8 pounds of boost-ish. And then as soon as it exceeds that, the only way it can exceed that is when the turbo kicks in. Then the turbo will essentially be bypassed. There's like a large throttle body in there that will just bypass whatever pumping the supercharger does. There'll just be essentially no pressure from the inlet to the outlet. So it'll still spin, but it won't really do anything. And then the turbo will take over. So you get the efficiency of the turbo at high speed and you get boost at low speed. This thing needs both, right? You want a lot of torque at low RPM, so 8 pounds of boost at 1,000 RPM is nice for four-wheeling because you always have it on demand. But then you don't have all the heat generated with the 8 pounds of boost with an Eaton is kind of pushing the limits of what it's really designed for. It's really designed for like 6 pounds of boost. So you lose, 5, 6, 7 pounds of efficiency depending on the speed. So anyway, that's what that is. There's the intercooler there. It's liquid to air. There's also an intercooler inside the manifold. So this is the charge air cooler for the turbo. And then there's another charge air cooler for the supercharger. When the turbo is working, it'll go through them in series. So it'll be pre-cooled by this, and then it'll go through the intake and be cooled by the second one as well. No additional heat will be generated, or very little, by the Eaton supercharger. Yeah, let's see. I don't have the turbocharger drawn in here because I don't have a good model of it, but that's essentially there's the mount for it. I had to make the mount. So that's the mount for the turbocharger. This is simplification of the compressor housing. This is what the exhaust look like. It's already on the car. This is the air filter. Obviously the differentials. The differentials are approximations, transfer case approximation, transmission approximation, right? Otherwise the model gets super heavy. Yeah, so I don't know what else we want to zoom in on here, but suspension is pretty unique on this. So Some of you will recognize the dashboard. Let's just start hiding stuff here now. Get rid of that roof. Turn this all on later. So yeah, dash panel. So the dash, what I've done is taken the original dash, gotten rid of this cluster over here that sucks because it's kind of really far out of view, and gauges are tiny on it, and you got to look between the steering wheel and tilt. Yeah, it's just terrible, right? It's one of the worst things with the Bronco. So I put normal gauges in here, so there'll be oil pressure and speed and RPM here, and then other ancillary gauges, boost and whatever, amperes and volts and yada yada yada. I've also left there's a bunch of rocker switches for winch stuff and lights and crap like that. I've moved the um, glove box door over because one of the major problems with Broncos is when you put a roll cage in it, you can't open the glove box door or the wing window. So I moved the glove box door over, and then the roll cage will be in a more appropriate position so you can open the wing windows. Those are a nice feature of older cars that I don't know why people got rid of them, but I like them. So I also have some USB plugs for charging phones, and then this ashtray is like a cubby for cell phones and packs of gum, whatever you want to stick in there. It's just like a little cubby, no door. So yeah, let's get rid of the body because that's hiding all the interesting giblets. Again, this is just a simplification of what the real body panels look like. Um, so one of the other things that I've done here, I'm not sure where they're hiding, but I'm using the skid plates as like there's a 3-inch, 3.5-inch OD tube, quarter-inch wall tube going along each side, and one of them's an air inlet, so it'll feed air if you're doing like heavy-duty four-wheeling in a lot of mud. It has a air filter that's mounted up high that feeds air to the air filter down here. This purple thing is the air filter housing, and then that feeds it into the inlet of the compressor, and then the outlet of the compressor goes to the other skid plate or rock slider, and then it goes up to the intercooler. Um, so that's what that is. So I can delete the intercooler now, at least hide it. We don't need all this. All right, and let's not worry about this guy. That probably won't happen. Okay, so now we just have a dashboard and get rid of some of this fender stuff. All right, so now we're getting down to the nitty gritty. Get the core support out of here. So one of the things that, if you've already done any serious four-wheeling, you get the vehicle on a pretty crazy angle, and all you hear is tick, 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 tick. That's because your engine's starving for oil. So this here is a dry sump tank. So this is already built as well. Just open that assembly up. Oops. Back up. Open. So it has a series of baffles and stuff in here. So this is just a filler. The oil. This is the inlet. So the oil comes up through there and then goes to the dry sump pump, which is inside the inside the motor, and then it returns it back to here, and then this has a bunch of time to uh, let the bubbles settle out of the oil and go back to here. And so this is um, my own design based on, I don't know, how gravity works and stuff. But um, I've had that problem on vehicles I've owned and done four-wheeling with, and some that I haven't owned. So sorry about that. A1 used cars. My buddy used to work at a used car lot, and one weekend he decided to bring a International Scout home, and we took it up some pretty gnarly trails, and it came back kind of broken. Put it back on the lot, made believe we never borrowed it. Um, so this is a old school Warren winch. Um, so I kind of like these ones are kind of built tough. So I had one on my Bronco, and so I decided instead of letting it hang out of the front and screwing up the CG and bouncing into rocks and stuff, I kind of hid it inside here. Um, so that mount is done. I still need to make this guy here, but kind of a bash card. It hasn't been made yet, but I know what it looks like. That guy, hide the winch. Okay, now we're getting into the nitty gritty. Let's hide this motor because this is like a little adapter that drives the onboard air compressor. So this is what the front suspension looked like, and the rear is very similar. So we'll get into the front, and then yeah, I'm sure there'll be some questions and comments in the yeah, a lot of stuff happening here. So let's kind of hide. Everybody knows what a wheel and tire looks like, so I'll hide those guys. So these are Audi or Porsche Cayenne brake calipers. Um, these are Ford F-150 rotors, and this unitized bearing is from an F-150 as well. As are the axles, except for Bronco's quite a bit narrower, so probably going to have a little bit shorter axle. There's two lengths in the standard, and I'm going to try to use one. I'm trying to use the short one, but I think it's still going to have to be a little bit shortened. But let's go back to the general design of this thing. So instead of having a live axle, I have an independent suspension that's mounted to this, what I call a diff box. The differential is mounted in this purple box here. And this purple box rotates relative to the frame. And then all the suspension arms are attached to that. So when you're just driving on the street, not doing any articulating requirements, you have an independent suspension. You have, I think it's like 8 inches of travel. It's been a while since I've looked into the details of it, but so you have 8 inches of travel with this thing articulating 0, right? If that was just locked to the frame, you'd have 8 inches travel inside, which is not terrible, but it's not great either. But then when you start doing like rock crawling or something where you need to flex, then this box can rotate, and it looks like it's rotated about in its maximum position here, where it's just getting close to the frame, and it's not that much. It's like 11 degrees or something. It's not a big number, but 11 degrees over 7.5 feet wide vehicle, you get a lot of extra articulation out of that. So that's the concept that I'm using here. I get the ride quality and all the benefits of an independent suspension without the detriments, right? We still can flex a lot and have a lot of articulation. There's also some challenge with it, of course, right? Your steering, there's a rack and pinion steering. So that's mounted to the diff box as well. There's the steering shaft going to it. So this has to plunge, right? The steering shaft has to plunge, which is, I mean, it's pretty normal for a steering shaft to plunge, but this has to plunge a lot now. And then instead of using the steering box to take all the forces from the sides of the tires, and you know, those typically are a failure point. I have some hydraulic cylinders in here. So there's actually the spool valves inside here. If you don't know what a spool valve is, it's basically a torsion bar on a valve. So as soon as you put some steering effort into the steering wheel, it depending on which direction you're applying torque, it opens holes a different amount. Um, and so it either pushes on, it puts fluid to this side of it or this side of it, and this whole steering rack is the hydraulic cylinder. So I'm just using the spool from the steering rack, and there's external lines that run anyway, so I'm just running those external lines to this cylinder and to this cylinder. So the spool valve, the hydraulic pressure from the power steering pump goes into this um, power steering rack and pinion, and then it goes to this steering rack or this steering rack, which is now a hydraulic cylinder. Um, and that's connected directly to, um, used to use an NX at work, so this mouse is backwards, but anyway. Um, so it puts the load right into where the tie rod is. So, um, so all these parts I've had to, fabricate, or most of this stuff is built now. I have these cylinders, I have the rack. I shortened one side of it because it used to be offset, and now it's less offset. Um, so that's the basic gist of the suspension. Um, well, there's a lot more. You notice there's a whole bunch of springs and shocks and things laying around here. Um, so we'll get into those as well. So it looks like I'm a little bit far out of my travel here. Um, so another interesting piece of information that many of us know, many of us don't, is when you're driving on the street, you want a fairly stiffly sprung vehicle. Otherwise, it's not very stable at high speeds. It's big and floppy and whatever. So typically, if you make a really hardcore wheeling machine, you put some really light springs on it, 100, 120 pounds per inch kind of springs, like super soft. And I don't know if you ever watched the stadium super trucks, but those things, lean and pick up tires and stuff because the suspension is just really soft. And that's not good for the street. It's good for off-roading. It's good for articulation. It's good for absorbing big whoop-de-doos, whatever. But really, what you want is to flip a switch and have a soft spring when you're off-roading, or flip a switch and stiffen it up for when you're in the street. So what I've done here essentially does that and change the ride height at the same time. So um, actually, that's an older version of the design, and this is the current design. So ignore that other side. Let's go down out of the way a little bit. So basically, how this works is this is an airbag, but it's made for like a strut suspension, and this is a Fox coilover, 14 inches of travel, I think. Um, and it has the springs in series. And this one has a built-in bump stop. So this air spring has a bump stop built in. So basically, when you are on the street, you just let the air out of this airbag, and then this just acts as a solid block, right? It's not part of the spring in series solution, right? All you have is this spring right here. So you can make this spring fairly stiff, right? This could be 400 pounds per inch or 350 pounds per inch. I have a spreadsheet somewhere that says what I'm going to start off with, but Doesn't matter. It can be stiff. It could be enough to, you know, cruise along 80 miles an hour and you're not worried about a little gust of wind tipping you over. And then when you want to go off road, you fill up the airbags. Um, and then now you have, instead of this spring, which is acting on its own, but you have this spring and this spring in series. And the way springs add is if this one's 300 pounds and this one's 300 pounds, it's the addition of the inverse of that. So um, let's say this was, just to make the math easy, if this was 200 pounds, this 200 pounds, you put two of them in series, now it's 100 pounds. Um, so that's what I've done here. I've not only do you get a higher ride height when you're off-roading, but your spring rate essentially drops in half or less than half, depending on the air pressure in this. So that's a nice little benefit. You get both at the same time, right? Put some air in this, it raises the ride height. Um, for off-roading, you get more ground clearance and more articulation, but you also reduce the spring rate. This spring, I'm not sure why that's in the wrong spot, but links. This spring is its sole purpose is to keep this diff box centered. So it's just like it's a righting spring, very light spring, but you have to have something to keep this diff box so it doesn't just kind of meander this way, that way, the other way. So that's 4 of the springs. You'll probably notice that there's some other springs in here as well, and another cylinder. So this is a Frick cylinder. And yeah, I'm sure there's some blank stares going on right now. What the hell is a Frick cylinder? Well, front rear interconnect is what it stands for. And so basically this is a hydraulic cylinder, and there's another one on each corner, but there's another one that has hydraulic lines running from this one to the this is the left front, so the right rear is its partner. So front rear interconnect, but it's diagonally interconnected. So what happens is when this wheel bumps, which is up, it it pushes fluid through this, and then that fluid goes to the right to the right rear wheel, and it pulls it up. So when this one goes up, it tries to pull the opposite corner up. When this one goes down, it tries to pull the opposite corner down. And if you think about how that would work as a system, it works when you're trying to articulate over, like you have sway bars still, right? So if you're trying to go around a corner on the street, this one's trying to compress, right? So it tries to pull this one up. This one's trying to compress, so it pulls this one up. So basically all you get is a lowered ride height. It works just like a sway bar, except for they're coupled diagonally. So when you're doing acceleration or braking, you get to anti-dive and an anti-squat, right? If you're putting on the brakes, the left front is trying to go up, which is going to pull this one up, and this one's going to try to go up, and it's going to try to pull this one up. So you get an anti-dive scenario and you get an anti-squat scenario. So I don't know why everybody on the planet doesn't do this, because it's I think it's just expensive, but that's what I'm going to do. So so that's what these springs and the reason it needs springs and shocks is because you can't. It's like if you didn't have a spring and you only had hydraulics, it would be a one-to-one movement. Like if this moved an inch on the left front, then the rear would have to move 1 inch, right? It would be like mechanically coupled. It'd be like having an infinitely stiff sway bar, which obviously that doesn't work. If you have an infinitely stiff sway bar, then you might as well have infinitely stiff springs, right? So this is acting like these coil springs are acting like the twisting of the sway bar. So you only need them on one end, right? So the rear doesn't have these springs. The rear just has these hydraulic cylinders. So that's how the Frick works. The rear suspension is like I said, very similar, except for instead of the fric cylinders being mounted the same direction, they have to be opposite, right? Because you have to put fluid. So the way hydraulic cylinders work is there's a piston that's, you know, an inch or whatever, and then the opposite side where this rod comes through the seal, and say that's a half-inch rod. Now you have a 1 inch cylinder minus the area of that half-inch rod. So the ratio is not the same from this one to this one. So if you wanted to um, be similar travel for the same fluid, you have to make one have a pusher and one have a puller, or you have to have a seal on both ends. You have to have a seal on the top and the bottom, on the front and the rear. And I didn't want to do that because then that that seal has another leak path. Plus, there's a big rod sticking out of it that poke through the hood and stuff. So that's why I didn't do that. Um, so yeah, so that's the 5-minute tutorial on what I'm doing and why I'm doing it. The devil's in the details, of course. So this one has a differential, um, which is a 8.8 Ford differential. Um, I think I have a picture of it in here somewhere, representation of it somewhere. Da, da, da. Anyway, not sure where it is, but the rear's 9 3/8, I think, like a Sterling Ford / Sterling differential. But the same deal with the airbags, right? It has the same shocks. It has airbags. Um, very very similar. Just the packaging is different. So this is not ready for prime time, but there's a lot of ideas that get chopped up and thrown in here and then discarded, and so everything you're seeing is not is not real. One other thing I should probably mention is these uprights are not something you can steal. So this upright is a custom. It's a custom piece. So I have to make these or have them made. But I've already done the analysis on them there. Factor of safety of like 4, so should be fine. Stock frame. This is a ZF transmission. It's a 5-speed manual. Originally intended to be in like an F350 or something for with a V10, but modular motors have the same bolt pattern. So 4.6, 5.4, 6.8, they're all the same pattern. So I got this transmission from a V10. Should be plenty for what I'm doing with it. This is an Atlas transmission or a transfer case, Atlas 2. Yeah. So that's about it. There's the 44-gallon fuel tank. Yeah, I didn't really get into that much, but the stock fuel tank is like 14 gallons when it goes in the rear. Most people replace those with a 24-gallon, which is what I have. But then I've extended it. It normally stops here. I've extended it to all this stuff. So now it's like 44 gallons. So that'll be gasoline. And then the stock tank, the saddle tank that goes in here, um, that will be E85. And there's a second set of injectors in the valley. So as soon as you get to 8 pounds of boost, it shuts off the fuel or reduces the flow of gasoline to minimal. They're still on, but minimal. And then the majority of the fuel is 85. So you can not have to pull a bunch of timing out with shitty gas you can buy wherever you go. So I'm sure I'm forgetting about 80% of the intent on this vehicle, but probably a good overview to like and share and subscribe and all that fun stuff that we're looking for. So stay tuned. Thanks for watching. If you like this content and want more, subscribe, like, and share.